recording. All right, so starting with chapter 12, round things, moons, rings, and dwarf planets. So we will talk about things like Jovian moons. I believe this is Callisto, perhaps Ganymede, shown here. We'll talk about rings like Saturn's famous rings and find out, as comes as a surprise to some, that Saturn is not the only planet with rings, far from it. And revisit dwarf planets and talk about planets like Pluto. This lecture will include a discussion of the moons of each of the Jovian planets: Uranus, Jupiter, Neptune, and Saturn. All of the Jovian planets have systems of moons. All of those systems of moons contain more than 10 moons, and in some cases more than 50. We'll talk about rings in general, their structure, their origin, and what sets Saturn's rings apart. We'll also talk about the definition of dwarf planets and Pluto in particular. So here is our overview of the Jovian moon count as of when these slides were made. I say that because new moons are regularly discovered. It's almost always the next one further out, and there's no reason to expect that these numbers won't go up, but not dramatically, but with a few more discovered in the future. Jupiter has 79 observed moons, Saturn 82, Uranus 27, and Neptune 14. And we will focus on just 9 of the best, or the most interesting. And it's true, that's subjective. And some of the ones that we consider interesting today were not really looked at, in the past, because some recent mission has discovered something and now we care about it a bit more than we used to. All right, so let's look at some interesting moon sizes in cascading or descending order, starting with the largest moon in the solar system, Ganymede. Ganymede is the only moon that is bigger than a planet, okay? Because it's just a little bit bigger than Mercury. So that means Titan, which is a moon of Saturn. By the way, Ganymede is a moon of Jupiter. Well, Titan is smaller than Mercury, which means Mercury would kind of fit in between the two. All right, Titan has its own claims to fame, but it's not size, so I won't mention it for now. All right. Oh, I was wrong. Sorry. Titan's also bigger than a planet. I got to stop saying that Ganymede's the only one then. I forgot. Titan is also bigger than Mercury. But now we get to moons that stay in their lane and don't try to outdo planets, moving on to Callisto, which is just a little bit smaller than Mercury. Although I guess it's just because Mercury is so darn small, right? That it gets grouped together with moons. Next up is Io, taking a big step down here in terms of the size, followed up by our moon, right? Goes to show that we got a big moon. Then on to Europa. By the way, Callisto, Io, and Europa are all also moons of Jupiter, along with Ganymede. So far we've seen 4 moons of Jupiter and 1 moon of Saturn. Then we move on to Triton. Sorry for the weird separation of the word, but it's, the N goes at the end. And Triton is a moon of Neptune. Think, Neptune as a god carries a Triton around. On to Pluto, not a moon at all, but a dwarf planet, but good for comparison. Then Tatiana, not sure how to say it, but I think it's maybe it's Titiana. All right, Oberon, both characters from a Shakespeare play, I believe a Midsummer Night's Dream. Maybe I got that right. And then finally, Enceladus, the smallest moon that we find interesting in the context of these slides. So let's look at some moons of Uranus. All right. So here are Uranus's 6 largest moons. They're all rocky and icy. There's some resurfacing. So some of them don't have pristine craters showing a history all the way to the early solar system. Tatiana has a density of 1.7, and I'll point that out because it's much lower than a terrestrial planet, because these moons, when we say they're rocky and icy, we mean it. They're not really like terrestrial planets or even like our moon. They are more like, well, Pluto and Kuiper Belt objects. And if you remember when we first introduced the solar system, we kind of talked about this distinction. And it's because they have significant amounts of low density ice compared to high density rock in their interior. And that the reason that that's a big deal is because it just can't happen for planets or anything near the sun, where those ices would be liquefied and they would, rise to the surface as a liquid, right? They'd percolate up through the rock. But in the situation where the environment is sufficiently cold, the ices don't melt even during planet formation and deformation and differentiation. They remain in at least a slushy state. So they stay within the rock and they create rock ice compounds. So that's the key thing here, is that these are truly, there's ice all the way down. Dug miles into the moon, you'd still be finding ice veins throughout the rock. This moon is the largest of Uranus's moons. Okay, it has no atmosphere, just like our moon. So nothing to protect against incoming radiation, just bare rocky surface, no gases. It does have scarps like Mercury, which is a great review question. Where did Mercury's scarps come from? Oh, I'd love to see if anyone remembers, especially because it might be on the test. I will check chat. Does anyone remember? Where did Mercury's scarps come from? Those are the cliffs on Mercury. I think I erased those slides, but you would have read about it in the book, or if you reviewed the slides. Okay. Okay. Alexander, you got it. Oh, anyone else? Yeah, Laura, nice work. Shrinking of the planet. And it points out these other features, right? Raising, lowering, we see that on Venus, Riles on the moon, collapsing, all right, channels on Mars, ancient water, but none of those apply to Mercury or Tatiana. Instead, it's the shrinking. When the planet finished differentiation, started cooling, releasing energy into space to reach some very low temperature equilibrium, then it literally collapsed and shrunk. All right. So their scarps are caused by the planet expanding. Interesting. In Mercury's case, it was shrinking, and then formed long valleys too, similar to the Valles Marineris on Mars. So the fact that it coincides with expanding rather than shrinking probably is going to be this tie-in that we're going to see a lot, that these moons have the capability of being surprisingly geologically active. And it's going to be because of all that ice and its low melting point combined with lots of tidal friction. Remember, these moons orbit gas planets. It's not like our moon orbiting a small terrestrial world. And so the tidal interactions can be incredibly dramatic on the moon. Insignificant on the gas giant, in the Jovian world, but very significant on the moon, and can keep the moon grinding inside, distorting, and therefore creating heat. So perhaps that's what caused the expanding, but I'm not sure. Unless it's referring to early in its formation, but why would it have expanded after it was formed. Check time. We just do a couple more slides. See if we can finish Uranus. Oberon is the other moon that we care about for Uranus. Okay, so the named moons for Uranus are just going to be Tatiana and Oberon. Oberon, similar density, right? Instead of 1.71, 1.63, because it's made of similar combination of rock, asimilar combination of rock and ice. It's the second largest, no atmosphere, right? So very similar characteristics. And as I mentioned, the names. Yep. So here it is, the reconciliation of Oberon and Tatiana, which come from mythology. And then Midsummer's Night Dream. I always want to say Midsummer Night's Dream, but it's Midsummer's Night Dream. I put the parenthesis S in the wrong place. So Oberon's king of the fairies, and his wife Tatiana is the queen of the fairies. That's the play that has Puck in it, if you know. All right, so they're named for characters by William Shakespeare or Alexander Pope. And that's kind of, in contrast, because most other ones come straight from mythology, Roman mythology or Greek mythology. All right, so we see Mars's moons, sons of Greek god, Aries, because Mars is associated with Aries. Jupiter's moons, mostly children or lovers of Jupiter / Zeus. And then Saturn's moons are named for the Titans, so the precursor to the gods in Greek Roman mythology. And then we have Neptune's moons named for the Greek ocean gods. All right. So we'll leave it off there. And next time, we'll jump right into talking about the Galilean moons of Jupiter. Stop recording.